tutorials, we are going to talk about how to solve first order linear differential equations using the integrating factor method. Now, the first order linear differential equations are in the form dy over dx plus p of x y equals q of x. In some books too, you find y prime plus p of x y equals q of x. Because dy over dx is sometimes written as y prime. Alright. So when you have your differential equation in the linear form, you determine your values for p of x and q of x by comparing it to what? To the original equation. Then after determining your p of x and q of x, then you find the integrating factor, which is I of x, given by e to the power integral of p of x dx. So you use the p of x to find your integrating factor given by this. Then when you are done finding your integrating factor, then you find your solution. So y will be equal to 1 over I of x multiplying the integral of I of x multiplying q of x dx plus c. So this will be the general solution for the first order linear differential equation when you are using the method of integrating factor. So you determine the p of x and your q of x, and you use the p of x to find your I of x. You substitute everything in here, and you integrate the product of I of x and q of x, then you have your solution. So let's start with an example. Find the solution to the differential equation y prime plus 2y equals 2e to the power x. So this is our differential equation solution. I have y prime plus 2y equals 2e to the power x. So I can compare this to the general formula y prime plus p of x y equals q of x. So if I compare this to this, the coefficient of y, which is p of x, is what? 2. And here the coefficient of, here the function of x here is what? 2e to the power x. So these are my values for x and y. So after determining the values of p of x and q of x, then you find your integrating factor, which is given by e to the power integral of p of x dx. We already know our p of x. So when we substitute it in here, we are going to have e integral of p of x, which is what? 2x. Right. So y of x is going to give us e. When you integrate 2 with respect to x, you are going to have 2x. Right. So this is our integrating factor. You know that the solution is going to be y equals 1 over I of x multiplying integral of I of x multiplying q of x dx plus c. So now I have my q of x and I of x. I just do my substitution. So 1 over I of x, which is e to the power 2x multiplying the integral of I of x as e to the power 2x is also multiplying q of x. Our q of x is what? 2e to the power x. So 2e to the power x dx plus c. So y is going to give us 1 over e to the power 2x integral of, here you're going to have 2e to the power 3x dx plus c. Law of indices. If the bases are the same and they are multiplying, we add the powers. So 2x plus 3x. So e to the power 3x, and we have our 2 multiplying there, right? So now we are going to integrate 2e to the power 3x. So 2e to the power 3x all over 3 plus c. Don't forget that when you are integrating the e functions, when you have e to the power, let's say ax, you have you write the e to the power ax, you write the original function and divide the function by the derivative of the exponent. So here the exponent is ax and the derivative will be what? A. So the same way we have e to the power 3x. So if we integrate, we have e to the power 3x and we divide by the what? The derivative of the exponent, which is 3. So that's how come we had e to the power 3x over 3. Here we were having to multiplying the whole function already. That's why we have 2e to the power 3x all over 3. Get rid of these stuffs. Okay, so that's what we are going to have. So I can distribute this, write it as 2e to the power 3x all over 3e to the power 2x plus c over e to the power 2x. So after that, we have e to the power 3x at the numerator and e to the power 2x at the denominator. So you can still use the idea of indices to get rid of some of the. So y is going to be 2 over 3, then e to the power 3x minus 2x. So you're going to have e to the power x plus, here we can write this as c e to the power negative 2x. So this is going to be our final answer. This is going to be our solution. When we find the solution to y prime plus 2y equals to e to the power x, that is what we are going to get at the end of the day. Alright, let's take another example. Let's find a solution to this differential equation. X y prime plus 4y equals 2x cubed. Alright, so this is the differential equation that we have. Alright, let's compare it to the original differential equation. The original formula, y prime plus p of x y equals q of x. Now, if we can note something here, always the coefficient of the derivative, that's the dy over x, is supposed to be 1. But here we are having an x here. So what you are going to do is to divide the whole differential equation. You divide through by x so that the coefficient will be 1, not what? X. Right? We're having x multiplying y prime like this. So let's divide through by x. If we do that, you're going to have y prime plus 4y over x equals 2x squared. Now the coefficient of y prime or dy over the x is now at 1. So we can now compare it to the general equation. So y prime plus p of x y equals q of x. So always make sure that the coefficient of y prime or the coefficient of dy over the x is 1. So if you have any variable or any value multiplying the y prime, you have to divide through to get rid of that variable so that the coefficient of the y prime will be 1. Because it is only that condition that you can compare to the original differential equation, since the original differential equation has its coefficient to be 1. So now we can just compare this to this. By so doing, our p of x will equal to what? 4 over x, because this more or less like 4 over x multiplying what? Y, right? Here our q of x is going to be what? 2x squared. Okay, now we have our p of x and our q of x. The next thing to do is to find our integrating factor I of x, which is given by e multiply the integral of p of x dx. So our I of x is going to be equal to e integral of p of x, which is what? 4 over x dx. So I of x is going to be e. When we integrate 4 over x, we will have 4 multiplying the natural log of what? X, right? So I of x is going to be equal to e natural log of x. 4 ln x can be rewritten as 4 ln x to the power 4, because log, if you have log, let's say you have log a to the base b of c, you can rewrite this as log base b c to the power e. So here we had natural log for multiplying natural log of what? X. You can rewrite this as natural log of x to the power 4. So that's exactly what we did over there. Okay, and we also know that when you have e to the power natural log of any function or anything, let's say e, we are going to have e. So e to the power natural log of 4 is going to give us 4, right? E to the power natural log of, let's say, x is going to give us x. E to the power natural log of x to the power 4 is going to give us x to the power 4. So if that is the case, our q of x was 2x squared. Alright, so if that is the case, then we can say e to the power natural log of x to the power 4 can be written as x to the power 4, just like this, right? Okay, now we have our integrating factor. Then find our what? General solution as 1, y equals 1 over integrating factor multiplying the integral of I of x multiplying q of x dx plus c. So we have our I of x, so 1 over x to the power 4 multiplying integral of x to the power 4 multiplying q of x, and this q of x, 2x squared x plus c. So our y is going to give us 1 over x to the power 4 integral of 2x to the power 6 x plus c. Then we integrate. We have 1 over x to the power 4. When we integrate 2x to the power 4, we are going to have 2x to the power 7. Sorry. 2x to the power 7 all over 7 plus c. So here we can have y equals 2x to the power 7 all over 7x to the power 4 plus c over x to the power 4. So from here we can do some simplification to have y equals 2 over 7 multiplying x cubed plus c over x to the power 4. This becomes our final answer. This y becomes our final answer. So that is how we solve first order linear differential equation using the integrating factor method. Let's try another example. Let's say we have x minus 2 multiplying y prime plus y equals x squared minus 4. So how are we going to solve this differential equation? So first of all, if we compare it to y prime plus p of x y equals q of x, you can see that we are having x minus 2 as the coefficient of the y prime. We have to get rid of that. So we have to divide through by what? X minus 2. X minus 2 here to x minus 2. That we are going to have y prime plus y all over x minus 2 plus here we have x squared minus 4, which is the same as x squared minus what? 2 squared, right? So the idea of difference of two squares. So x squared minus 2 squared all over x minus 2. So our y prime plus y, or let's say 1 over x minus 2 y will be equal to x plus 2 multiplying x minus 2 all over x minus 2. This will cancel this. So y prime plus 1 over x minus 2 y will be equal to just x plus 2. So we can now compare this to y prime plus p of x y plus q of x. So now p of x is equal to 1 over x minus 2, and our q of x is equal to x plus 2, right? And we find our integrating factor. I of x equals e integral of p of x dx. So we are going to have I of x equals e multiplying integral of p of x, which is what? 1 over x minus 2 dx. I of x is going to be e to the power natural log of x minus 2, right? Because when we have let's say 1 over x minus 2, this when we divide when we differentiate the numerator, we get the when we differentiate the denominator, we get the numerator. So it's simply going to give us natural log of what? X minus 2. We did this in integration, that when you have a function such that when you differentiate the denominator, it gives you the numerator, then the integral of that function is the natural log of the denominator. So that's the idea that we apply. Or you can use the u substitution. You can let u equals x minus 2. So the u will be equal to what? Just the x. So when you substitute it, you are going to have something like 1 over u. U equals the x over du, right? So 1 over u, when you integrate that, you get natural log of u. And our u is what? X minus 2. So that's how come we had this, right? Use these things. Okay, so now we have e equals I of x equals e to the power natural log of x minus 2. So our I of x is simply x minus 2, because e to the power natural log of any function is just that function. So having our integrating factor, so now say our y equals 1 over the integrating factor multiplying integral of the product of the integrating factor and the what? Q of x dx plus c. So our y is going to be 1 over the integrating factor, which is x minus 2, integral of I of x, which is what? X minus 2, multiplying q of x. This is our q of x, x plus 2, x plus 2, x plus what? C. Alright, so y will go to 1 over x minus 2 integral of this one. You can just distribute You can multiply x by x plus 2 and negative 2 by x plus 2, then you integrate. Or we have x minus 2 here, x plus 2 here, so it's obvious that this is going to give us difference of two squares. So by just inspecting, I know that this is going to give me x squared minus what? 4x plus c. Alright, so if I have x squared minus 4 dx, I'm simply going to what? Integrate that, and I'm good to go. So y is going to be 1 over x minus 2 multiplying, when I integrate x squared, I'm going to have x cubed over 3 minus, when I integrate 4 with respect to x, I'm going to have 4x plus c. Alright, make space over here. Okay, so we have y equals, we have this. Alright, so y can be equal to x cubed, we are distributing, all over 3 multiplying x minus 2 minus 4x all over x minus 2 plus c all over what? X minus 2. So this becomes our solution to the differential equation. Alright, let's try one more example. Let's say we have dy over x equals, dy over the x equals 1 plus 3 tan x multiplying y. This is the differential equation that we have. So I can rearrange this. I can rewrite this because I want this to resemble the linear form. Then I compare it to my equation. Then I get my p of x and q of x. So I can rewrite that dy over dx minus tan x multiplying y equals 1. Just like this. 3, sorry. There's 3 here. 3 tan x multiplying y. Alright. So if I have this, I can compare this to dy over dx plus p of x y equals what? Q of x. So my p of x is going to be minus 3 tan x. My q of x is going to be just 1. My integrating factor, integral e to the power integral of p of x dx. So I of x, just substitute p of x here, which is negative 3 tan x. So negative 3 tan x dx. I of x is going to give us e to bracket to the power negative 3 integral of what? Tan x dx. Alright, now when we integrate tan x, what are we going to get? Now tan x is the same as what? Sine x over cos x. Right, so when we differentiate cos x, we get negative sine x, right? So our integral for this is going to be simply negative natural log of what? The denominator. That's what you're going to have. Or you can use the u substitution. You let u equals cos x and you continue from there. So here we are going to have negative 3 multiplying the integral of tan x, which is negative ln cos x. Right. So this can also be rewritten as e to the power 3 multiplying natural log of what? Cos negative 3 multiplying negative natural log. So it's going to be positive cos x. I of x, using the idea of indices, we can say this is natural log of what? Cos x to the power 3, right? I of x, well, you know that e to the power ln a equals a. So e to the power ln cos x all cube is what? Cos x all cube, which is the same as what? Cos cubed x. Alright, so now we have our integrating factor. Let's find our y. So our y is going to be 1 over the integrating factor multiplying integrating factor x plus c. Let's substitute in our values. 1 over our I of x is what? Cos cubed x multiplying integral of I of x, which is what? Cos cubed x multiplying q of x, which is 1. So let me just maintain the cos cubed x, because cos cubed x multiplying 1 is cos cubed x dx plus c. Alright, so yeah, our challenge is to integrate cos cubed x. So let's see how we are going to do that. Alright, few minutes. Alright, let's continue. So integral of cos cubed x dx, that's our challenge now. But we can write cos cubed dx as cos squared x multiplying cos x, right? And cos squared x is also 1 minus what? Sine squared x multiplying cos x. So when we distribute this, we are going to have cos x minus sine squared x multiplying cos x. So integral of cos cubed x dx is the same as integral of the whole of this dx, right? And the whole of this, you can also write it as integral of cos x dx minus integral of sine squared x cos x dx, right? Right. So when we integrate cos x, that one is easy. When we integrate cos x, we are going to have negative sine x minus integral of what? Sine squared x cos x dx. So now here is our challenge again, sine squared x multiplying cos x. So we know that the first part, we are going to have negative sine x minus integral of sine squared x cos x dx. So let's integrate that part. That's this part. Let's do this separately. Okay. Want to integrate sine squared x multiplying cos x dx. Here we can use the idea of u substitution, because when I make sine x the subject, or when I let u equal sine x and I differentiate sine x, I'll get cos x. And if I make the x the subject, the cos x will come down. It will come to the bottom and it will take care of this. It will cancel this cos x. So let's do it. Let u equals what? Sine x. So du will be equal to, when we differentiate sine x, we get what? Cos x dx, right? So our dx is going to be du over cos x. So integral of, we said let u equal sine x, so we are going to have u squared, right? Cos x multiplying the x. Now the x is du over cos x. So this will cancel this. We are going to have just integral of u squared du. So when we integrate u squared du, we are going to have what? 1 over 3 u cubed. When sorry, the integral will not come again. We are done integrating. So 1 over 3, but our u is what? Sine x. So sine cubed x, right? So when we integrate sine squared x cos x, we are going to have 1 over 3 sine cubed x. And we already have our negative sine x here. So integrating that's cos cubed x, we are going to have negative sine x minus 1 over 3 sine cubed x. This is what you are going to have. So let's put this here. So y will be equal to 1 over cos cubed x multiplying negative sine x minus sine cubed x plus c. What you are going to have. You can go ahead and do some small simplification if you wish, or depending on what the answer requires. So let's simplify further and see. So let's distribute this. So we are going to have y equals negative sine x over cos cubed x minus sine cubed x over cos cubed x plus c over cos cubed x. Y will be equal to we can write that negative sine x all over, let's say, cos squared x multiplying what? Cos x, so that this will give us cos cubed x. But sine cubed x over cos cubed x, what? Tan cubed x plus c over cos cubed x. So y can also be rewritten as negative sine x over this sine x over this cos x is going to give us negative tan x multiplying 1 over cos squared x minus tan cubed x plus c over cos cubed x. Y will be equal to negative tan x. What is 1 over cos squared x? 1 over cos is what? Sec. So we can have sec squared x minus tan cubed x plus c over cos cubed x, or negative tan x sec squared x minus tan cubed x plus 1 over cos cubed. So we can have sec cubed x multiplying c. This will be our final answer when you go ahead and do further simplification. So this is how we this is how we find a solution to first order linear differential equation using the integrating factor